Good morning, CSEC students. Welcome to another live CSEC class. This morning, focus is on matrices, and we'll be zeroing in on matrix multiplication, scalar multiplication, and regular multiplication of matrices. That's our focus this morning, and we're going to get right into it. But we're also going to give ourselves some time to get on. So just a minute for the scholars to log on while we get started. So we're going to start with scalar multiplication. And multiplication has to do with multiplying a matrix by a scalar quantity, by a whole number, a fraction, in some cases, a decimal. And it's really, really simple. So let's say we have 2, 4, 2, 5. I'm going to up scholars. Let's say we have 1/3, 5, 6, 3, -3, 9. Right, so let's say we have that. We're going to start with these. So let me check to see who is on. So scholars, as soon as join, just let me on, just say good morning, say here, present, in the house. Let's get the party started. Miss anything, say, okay? All right. So scalar multiplication. Well, the last matrices that we did, we looked at of matrices and how we read matrices. So these two matrices that are on now, that you're looking at, these are 2x2 matrices. So we have 2 rows and 2 columns. All right, so I'm seeing Jamani, I'm seeing Carissa, I'm seeing Imani so far in the chat. Other scholars, please log on and let me know that you're here. So what we the order of the matrix. So for this matrix, it's a 2x2. So we have 2 rows. The 4 and the 1 are in 1 row. That's 1 row. The 2 and -5 are in another row. So that's 1 row, 2 rows. And the columns go vertically. So rows go horizontally, rows go vertically. So the 4 and the 2 are in 1 column. The 1 and the -5 are in column. So 2 rows, 2 columns. Likewise for this matrix, the 5 and the 6 are in 1 row. The -3 and the 9 are in another row. So that's 1, 2 rows and columns. 5, -3, that's in 1 column. 6, 9 in another column. So the scale quantity is the number on the outside, and we're going to, all we're doing really is multiplying each of numbers in the brackets by the number outside. That's plain and simple how we do. So answer for this first one, so it would be 2 times 4, which is 8. 2 times 1 is 2. 2 times 2, which is 4. And 2 times negative, which is negative 10. That's all there is. That's really and truly all there is to it. So let's know. So we're multiplying everything in the bracket by -3 thirds. Sorry. So in matrices, we are allowed to leave improper fractions as they are. You can change it to a mixed number if you want, but you're allowed to leave an improper fraction there. So if we're multiplying 1/3 by 5, so let's do that to the side. So 1/3 times 5/1 is a whole number. So 1 times 5 is 5. 3 times. So we would get 5/3. So our answer will be 5/3. Likewise, if we work 1/3 times the 6. So 1/3 times 6/1 with 6. So 1 times 6 is 6, 3 times 1, 3. And is 2. So for that one, we would have 2. 3 would give a -1. Using the same format, get a -1. 1/3 would give a +3. So that's our answer for this one. 5, 2, -1, and 3. All right, let's do a couple more scalar multiplication before we go on to the more complex one where we're going to be multiplying a 2x2 matrix by 2x2 matrix. That is a little more complicated. Scalar. So let's say we have the scalar is -3/4. And inside the matrix of -1, we have 16, we 4, and we have -5. And let's over here now, we have 7, we have 0, we have 1, we have negative. All right, so we're multiplying each of the numbers here by the -1/3. So if we have -3/4, sorry, why am I saying one? I'm saying all kind of madness this morning. -3/4 times -1. Negative times negative is positive, and anything times 1 is the same. So for here we'd end up with a positive. So in this section here, where the -1 was, we'll have 3/4. 3/4 times 16, so let's work that one. So -3/4, I will multiply that by 61. 4 into itself goes 1. goes 4. So we have negative 3 times 4 is 12. 3/4 times 16 is negative 12. No fraction, just negative 12. So negative quarters times 4, the cancel this 4. I call the 4 cancel the 16. And we'd have 1. So all we'll be left with is the negative 3. And negative 3/4 times negative 5. So nothing there could cancel. So we'd end up with a positive. So negative times negative positive. 3 5s, 15. So we'd have 15 and the 4 would still be in the denominator. So it will be 15 over 4. Like that. We can have a mixed number with 3 3/4. Or we can just leave 15 over 4. So let's do this one now. So we're multiplying each of in the bracket by 7. So remember, 7 times 0 is, let's work 7 times 14. So we have 7 times 1 over 14. Can put the 7 over 1. You know? So 7 into 7, 1. 7 into 14, 2. So we'll end up with 1 over 2. That's a half for this one. 7 times 21. So 7 ones, 7, 7, 14. And 7 times negative 6 is negative 2. All right, so that's it for the scalar multiplication. For the scalar multiplication, you would have a number in front of the matrix, whether it's a fraction or a decimal. It can be negative, it can be positive, whatever it is. It can even be a variable. Because remember, sometimes in matrices, you're given variables and you have to multiply it, expand it, it's just the same, and you will be asked to solve for the variable. So now we're going to go on to multiplying a matrix by 2 by matrix. And this one can get confusing. I myself get times. I need to go over, make sure you're doing it properly. So it takes focus. It can be very confusing. So what we have is a 2 by 2 matrix. And we're going to multiply it by another 2 by 2. So let's have 6. Sorry, hold on. Negative 6. So negative 6, 0, 5, 4. And then we have 3, 2, negative 6, 1. So we multiply column, row by column. So we're going to use this row to multiply this column. And then we're going to use that same row to multiply this column. So it's row by column. This row times this column, this row times that column. That's the first set. And then we're going to go down here. So that row times this column, and that row again times this column. So let's do it with actual numbers. Okay, so the first row, the negative 6, 0 times the 3, negative 6. So we're going to need a big bucket now because we're going to have all of those being multiplied. So the more we progress, the smaller the brackets will need to be. Negative 6 times 3. -6 times 3, and 0 times -6. Then we'll have 6 times 2, so -6, 2, and then, not properly, then 0 times 1. So row by column, row by column. All right, first row, first column. Let's go to the second row. So let me use a different color for those. The second row, it will be 5 times 3. So 5 times 3 and -6. And then 5 times 2 times 1. When you're finished, you should have your numbers lined up: 3 over the 3, -6 over -6, 2 over 2, 1 over 1. So that's how you know you're on the right track. Check out your matrices line up. So now we're going to work out each of these, and we're going to contract the brackets. So this is equal to so we need a smaller bracket. -6 times 3, that's negative. And 0 times -6 is 0. -6, -12. 0 times 1 is 0. So you see it's a small one because we're contracting the numbers. 5 times 3, 15. 4 times -6, that's -24. And 5 times 2, that's 10. 4 times 1, that's 4. And finally, we're going to add these. All right, so the smallest bracket now is we're going to end up with 2 by 2 matrix. So when you multiply a 2 by 2 matrix times a 2 by 2 matrix, you end up with another 2 by 2 matrix. So it's -18 minus 0, which is -18. 12 plus 0 is -12. 15 minus, so that's -9. And 10 is 14. So that's our first matrix, 2 by 2 by times 2 by 2. So have a look at it. Good morning, Dinsmore, and welcome. Haven't seen you in a while, sir. Where have you been? So have a look at it and see if you are figuring out the pattern row by column, row by column. If you're lost, just stick out of the water. Let us know you are drowning and we'll dive in for you. So let me know where, at what point did I lose? Did you understand the scalar multiplication? And now that we've gone on to the regular matrix multiplication, so we're multiplying a 2 by 2 matrix by another 2 by 2 matrix. For those who are not quite getting it, let's revise what we did. before we go on to another one, let's go over the bias. So we're multiplying each row by each column. So the first row is the negative 6, 0. Rows go horizontally. So negative 6, 0, that's in one row. And 5, 4, that's another. The columns would be the 3, negative 6. So columns go vertically. And the 2, 1. So row by column, so it's the negative 6 times the 3 and the 0 times the negative 6. And then negative times the 2 and 0 times 1. That's the first row. Now we go to the second row. We're going to multiply it by each column. 5 times the 3, 4 times negative 6. Then 5 times the 2, 4 times 1. Once that, we should check to make sure that we have whatever digit is here should be the same digit here. Whichever one here should be the same. Whatever is here should be the same as this one and this one. So just make a quick glance and make sure you have everything lined up. And then all you have to do now is work out the operations. Negative 6 times 3 is negative 18. 0 times negative 6 is 0. Negative 6 times 2 is negative 12. 0 times 1 is 0. 5, 3 is 15. 4 times negative 6, negative 4. 5 2s 10. 4 1s 4. And then we contract it further. We have more operations to work. Negative 18 minus 0 is negative 18. Negative 12 plus 0 is negative 12. 15 minus 24 is negative 9. 10 plus 4 is 14. All right. So let me hear what's doing. Everybody good? Oh, okay. All right, Dinsmore. Oh, you have church this week. Okay. All right, no problem. You are missed. You are missed, sir. But we just have to work with your time, right? Because I know everybody is busy. We have life going on. All right, guys. So let's jump into the next two. We're going to work 2 more examples of the 2 by multiplication. If you're good, just say, Miss, I'm good. I'm good. I'm good. If you understand, just say, Miss, I'm good. So let's go now. So we have 7, 3, 7, 3, 4 and a half. All right. And then we have 2, 8. Why my 6's never come? 4. And we're multiplying. So 2 by times 2 by 2. We know that first one we're going to need a great big bracket, great big. So let's just go and fill it all the way. We need a great big one for the first set. And let's use a different color so that we can see it clearly. So it's going to be by this column. So 7 times 6 and 3 times 8. So 7 times 6, 3 times 8. And then we're going to have 7 times negative 2 and 3 times negative 4. 7 times negative 2, 3 times negative. Then we do the next row and the next column. So we're going to have 4 times 6.5 times 8. 4 times 6.5 times 8. And the 4, so 4 negative 2.5 times negative 4. 4 times negative 2.5 times negative. Let's check if we have our, we have 6, 6, 8, 8, negative 2, negative 2, negative 4, negative 4. All right. So we're good for that. We're good with. So let's go now, and we need a medium size. So large brackets for the first, medium size for the second. And then we're going to end up with a small bit for the final answer with our 2 by 2. 7 times 6, that's 42. 3 times 8, that's 24. Positive 24. Negative 2 is negative 14. And 3 times negative 4 is negative 12. For the next set, 4 times 6. 4 times 6 is 24. And half times 8, that's a positive 4. Times negative 2 is negative 8. And a half times 4 is negative 2. So now we just find these. And we need just a small set of brackets now for our 2 by 2 matrix. 22 plus 25, and that will give you 66. Negative minus 12, that will give you negative 26. 24 plus 4, that's 28. And 8 minus 2 is negative 10. And that's our final answer. That's our final answer. We end up with a 2 by 2. So again, when you multiply a 2 by 2 matrix by another 2 by 2 matrix, you're going to end up a 2 by 2 matrix. So it's row by column. The first row is the 7 and the 3. And we'll multiply by the column 6, 8, and the next column negative 2, 4. 4.5. I will multiply each of those by the 6, 8, and the negative 4. So let's do one more. Let's do one. So we have 0, negative 1. And we have negative 6, 7. And we're multiplying that 2 by 2 matrix by another 2 by 2 matrix. 5, 3, 0, 6. All right. So for the first row, we're going to need a big brackets. And we'll have 0 times 5. And -1 times. So row by column. And the 0 times 3. Why is my mouse stucking on me? Come on. -1 times 3. Sorry, -1 times 6. Then the next set of columns. So it's going to be -6 times 5 and 7 times 0. And then times 3. And 7 times 6. So all we need to do now, is to combine the operations there in the brackets. So we need a medium size right now. All right, just have some issues with my mouse. It's stucking. Not allowing me to click the allow me to click my pen, my color. Why is my mouse behaving like this? All right, let's just wait and see if it will sort out. So we're going to working each operation there. So we're going to have saying 0 times 5, sorry, the -1 times 0, and then we're going to combine those two. And the 0 times 3 and -1 times 6, we're going to combine to -6 times 5 and 7 times 0, we're going to combine those. And -6 times 3, 7 times 6, we're going to combine. It seems as if my king. Let me go back and check now if I'm able to free up my pen. Okay, seems like all right. So let's see now. So we need a medium size pair of brackets here. And 5, that's 0. -1 times 0. 0 times 3 is 0. -1 times 6 is -6. -6 times 5, so that's -30. 7 times 0 is 0. -6 times 3, that's 15. 7 times 6 is a positive 42. And now we're going to draw our I don't know, this mouse is so much problem this morning. So much problem. What this mouse here about me this morning? your earboat this morning. We need a smaller set of brackets now. 0, that's 0. 0 minus 6 is negative 6. 30 plus negative 30. And negative 13, sorry, negative 18 plus 42, I believe, positive 20, I think. Okay, so positive 24. All right, so our final answer. What I will show you though is another thing. Remember the last matrices class that we did, we looked at addition and subtraction of matrices. Sometimes they will combine, as a matter of fact, more likely, or the way you're likely to see it in the exam is a combination. So where you're going to see them having scalar times a matrix plus another scalar times a matrix. So that's how you like. So let's do an example of that. So let's say you're given 3 matrices. You might be saying A is 4, 0, 1, 7, and matrix B would be 2, 6, negative 3, and matrix C would be negative 1, 3, 2, and 1. What they might ask you to do is find, so let's say find 2A plus 3B, A plus 3B minus C. That's how you're likely to see it. 2A plus 3B minus C. So you're going to have to use your scalar to multiply the 2 times A and the 3 times B, and then you're going to add and subtract the matrices. So let's see what we would get for that. So 2A would be 2 times 4, 0, 1, and we're going to add that to 3 B, which is 2, 6, 9, negative 3. And then we're going to take away C, which is 1, 3, negative 2, and 1. So we need to work those out now and bind them. So for this one, we'll have 2 times 8, 2 times 0, 2 ones, 2, 2 sevens, 14. We'll add that to 3 twos, 3 sixes, 18, 3 9, 27, 3 times negative 3, that's negative 9. And then we're going to take away -1, 3, -2, 1. And it's going to combine to 1 by 2 matrix, because they're all 2 by 2 matrices. All right, so as usual, we're going to work the operation on those that are same side of the bracket. So 8 plus 6 is 14 minus -1. So remember, 14 minus -1 is the same as saying 14 plus 1. When you take away a negative, it's the same as saying adding. So 6 is 14 plus 1, that will give 15. 0 plus 18 is 18, minus 3 would also give 15. 2 plus 20 is 79, minus -2, so this is plus 2. 29 plus 2 is 31. And 4 minus 9 is 5, minus 1 is 4. So let's go over that last set. So we're adding and subtracting those terms that are in the same corner of the bracket. So it's 8 plus 6, which is 14, minus -1, which gives 15. 0 plus 18 is 18, minus 3, that's also 15. 2 plus 27 is 29, minus -2, which is the same as adding 2, that's 31. And 14 minus 9 is 5, minus 1 is +4. All right, so we're going to leave it there for the matrix motion. This time we do matrices, we're going to be looking at the inverse of a matrix, finding the inverse of a matrix, which you could look at as dividing, because we're multiplying by the inverse. You know, when you're doing fractions, the divide is the same as to multiply by the inverse, right? And from there, we are going to look at solving simultaneous equations using matrices. So we have a lot to cover, and I'm going to go step by step. So that's it for matrix multiplication, scalar multiplication.